Okay, so we were looking into various terminologies, overviews, importance of BGP, uh, VXLAN, increased replication, um, BGP, EVPN, and so on. We are going to go in deep. Something very important I would like to touch before I go to lab so that your lab will be comfortable. Long time we are discussing about this components that builds up VXLAN EVPN. Let me start from the beginning, the components. First is the IGP protocol. The interior gateway protocol you can use like OSPF, ISIS, even EIGRP or static route. But again, I tell you, don't go with static route because we need ESMP. So advantage of ESMP, you know very well. That's very important feature of VXLAN should have. And then the purpose of this IGP, okay, let me write again, OSPF, ISIS, EIGRP. Now, if you use RIP, nothing wrong, but I don't know whether all devices will support RIP. In Nexus, you need to check. Some devices don't. So static route is supported everywhere. Yeah. So the goal of this routing protocol is to provide reachability between VTAP to VTAP. I hope you understand this. Means leaf to leaf, VTAP to VTAP. And very important point, which you already know, I'm going to tell. It's already known one, but kind of important. What is that? Let me ask you before I tell. If you are doing layer 3 MPLS VPN,
Yeah.
when you form peering, IBGP peering, what is the condition? IBGP peering, there is one condition.
Loop back to loop back.
Very good, loop back to loop back. Why loop back to loop back? That okay, no problem. You have redundant paths, but something more on loop back to loop back. When I say why loop back to loop back, you will say we got redundant paths. About those things, I'm happy with that. But there is one more point. Usually for loopback, tell me, Cloco. Usually for loopback interface, what we do? Go. Go. Are you there?
Yes. Yes, I'm here.
Usually for loopback
Yes,
interface, what do we do?
Yeah, loopback interface help us to.
No. Those things we already spoke. For loopback interface, what do you do? On the physical interface, the mask can be anything, but on the loopback interface, what?
/32.
Yes. See, you go to MPLS lab and see. If you don't have 32-bit mask on loopback, which you used to form peering, the ping won't happen between the customer sites. Everything will be working, looking good, outputs will look good, other than the reachability. The data plane cannot come up. So don't forget, the VTAP IP addresses must be 32 prefix width.
So why this
What?
requirement?
Why you are asking after this many days? Let me tell you the answer. Listen, what are all protocol involved in layer 3 VPN?
Uh,
OSPF.
BGP,
OSPF.
OSPF,
Let's
yeah.
start from OSPF. OSPF.
Sorry,
OSPF.
sorry, sorry. Can you repeat the question, please, Jay?
What are all the building blocks of L3 VPN? OSPF is one protocol, yes?
Yes, sir.
Yes.
What is the router ID size? What is the router ID size in
30,
OSPF? 32.
32 bit.
What is
32.
the size of MPLS router ID? 32 bit. What is the
Okay.
BGP's router ID size?
32
32
bit.
bit. When all these protocols are identified with 32 masks, if the neighbor address is /24, then the 8-bit last 8-bit won't match with the IDs. As a result, there won't be sync between data plane and control plane.
Okay, sir.
Hmm.
So, very important in all VPN concepts, especially layer 3 VPN concepts, that you must have the mask correct. You go back and do some later, do some lab on MPLS layer 3 VPN, which you know very well, which you have done many times. Now this time you just go and put mask as 24 and try doing it.
Okay, sir, I
Will
will
not
do that.
work.
You will see what I'm saying. Okay, it won't work. He has already seen that. Okay, so that rule is here, right? Because this is also VPN. Next building block is PIM, protocol independent multicasting. So in protocol independent multicasting, we are going to use this multicasting for bump traffic. See, you can also use the head-end replication, but it's not scalable. What is the instead of PIM, means instead of multicasting, you can use head-end replication. Head-end means whatever comes in, you send it to everyone whom you configured as peers. But the peers need to be manually configured. This is not a scalable solution. So depending on PIM is the best one. What is the goal of the PIM? What is the goal of multicasting? Forward the overlay bump traffic over the tunnel, over the tunnel. Over the tunnel, if you would like to forward some broadcast, unknown unicast, and multicast, you need multicast. So that's one thing. Another thing is in VXLAN, all the leaves, all leaves, but you will not write leaf spelling in English like this. Something like this only we write. But here, networking people are not that accurate in spelling. They write like this. All leaves or all VTAPs must be a multicast sender and receiver for every VNI. For every tunnel, there is multicast address to identify the remote tunnel endpoints, the remote peer. So all are sender as well as receiver. So PIM is important. That's what I want to say. PIM is important. So if you have PIM, what mode will you choose? Will you use shared tree or source-based tree? Or in another word, will you use flooding and pruning method or sparse mode or dense? Which one will you use? No option. You have only sparse mode. In Nexus, there is no dense mode available. That option is no more not available. Only sparse mode is available. Yeah. So we need an RP. If you say sparse mode, then there is a rendezvous point. Make all the spine to be a RP. Make all the spines to be RP, rendezvous point. We are not new to multicasting, so I'm not going much into it. You can use rendezvous point on both spine. If you want, you can use MSDP for synchronization between them. Multicast source discovery protocol. Or you can use bidirectional PIM. Yeah. That is more scalable. Bidirectional PIM is more scalable. Or we can also use, I have seen in VXLAN deployment, they use Anycast RP. So that's your choice, whichever you're comfortable. Anycast RP means what? The nearest RP. That's what Anycast RP. They go and report to the nearest RP. So if half of them reports to spine 1, which is an RP, if the other half reports to spine 2, which is also another RP, then there will be a non-sync. So for synchronization, you can use MSDP. So I repeat, you need RP. RPs are configured on spine. Rendezvous points are configured on spines. So in order to have scalability, I can use, in multicasting, I can use bidirectional PIM. And in order to have redundancy, if you want to have redundancy, you may use bidirectional PIM along with Anycast RP. Means this is an option to enable. You know what is bidirectional PIM? See, Anycast RP is nearest RP. Bidirectional PIM, when do we enable? Whenever a source can be a sender, can be a receiver, as well as receiver can be a source. Sorry, sender can be a receiver can be a source. Again, receiver can be a source can, sorry, why I'm telling source. If you have sender and the receiver role on every device, all will be sender, all will be receiver, which means whenever they send, they become source. Whenever they receive, they become group member. So all are source and all are group member. That is going to make your M route table very big because you have more source for the same group. Everyone is a sender as well as a receiver. Everyone is a source as well as the responder. In that case, you have to enable bidirectional PIM so that mroute table will not learn S. It will only learn G. For the S, it will always have star. Don't forget. So we have option called bidirectional PIM. You just enable it globally. When I do the lab, you will see. Next is we need BGP. That's the last component. MP BGP. Why do we need this? First thing is L2 VPN, EVPN, peering. Between what? Between peering between what? Leaf and spine. Even between the spine. But the encapsulation, decapsulation won't happen on spine. But for the route to get replicated, you need to go via the spine. So leaf and spine. So the goal of MPBGP is to advertise VXLAN L2 and L3 VNI information. This is what we were seeing last two classes. L2 information is passed through the tunnel. The MAC address information, the IP address of the original host. This is in order to reach that destination, which VTAP address to take, via which VNI it needs to go. That is a layer 3 actually, you know. So MPBGP is one of the important components. Next. Equal cost multipathing and MTU. Let's discuss about ECMP and MTU. See, in a layer 3 network, in order to do equal cost multipathing load balancing, how do we do? I'm talking about layer 3.
Cost must be same.
That is right. You see, cost is same. You have 5 links. All 5 link have the same cost. I'm not talking about that part of ECMP. That is why we call it as ECMP. But based on what you will do it, destination IP, isn't it? For their destination IP, I got this 5 paths equal,
Yeah.
correct?
Okay.
Yeah. So in layer 3 network, equal cost multipathing, that load balancing is based on any one of this 5 duplex, we say 5 duplex. Tuples, 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 5 tuples. Number 1, destination address. Destination IP address. 2, source IP address. 3, layer 4 protocol, like services. 4 destination layer 4 port number. 5 source layer 4 port number. See, using any one of this, load sharing can be done. If any one of this, see, out of this 5, for one of the traffic, if any one of this is different, it will take a separate tunnel. If all these 5 are same, if everything is identical, then it is going to have the same tunnel, because it's the same workload. If the source port number is different, then it is considered as different workload. It can say that this is a different session, this is a different workload. So it will provide a different path. See, please understand. I have 5 paths. So let's say you got 2 spine, you got 2 paths. How is the load balancing happens? Do you think half packet goes in this line and half packet goes in another line? No. If one session means if the source and destination port number, if source IP, which are all 5 that I said, no, destination IP, source IP, layer 4 protocol, destination port number, source port, if all these are same, it will only use one path, I tell you. Even though you got the other path, it won't use this path. If source port number varies, same IP, source IP is same, but what is this? A new session, different port number. Whenever a new session starts, there will be random port number, right? So there is a new port number, new session. It's going to take another path. Again, for another packet, there is another port number, source port, then this path. So for every packet, the source port number is the randomly generated and assigned by TCP. If you sniff packet using Wireshark, you can see that just telnet and see. All TCP packets will not have same port number. Source port number will be different. So your telnet traffic will not go through one path. It will go through multiple paths. The entire telnet is not one session. I did not mean that. Every packet that has got unique port number, source port number, will take one path. Did you understand this very important point? It provides the path if it finds any one of these 5 tuples different. Of course, if the destination address is different, it is going to give different path. If source address is going to be different, sometimes source, destination, protocol, all will be same. Even the destination port number will be same, but the source port number will be different. It's going to give different path. Did you understand that point?
Yes, sir.
Okay. Now, because of VXLAN, you're going to add 50 bytes of overhead. So to your original frame, 50 bytes of information is overloaded, attached, overhead. So what we have to do is in the underlay network, please note, in the underlay network, that because there is a physical network. In the underlay network, we need to increase 50 bytes. See, if the original traffic that is generated from your host computer is 1500 bytes, so we need to increase the MTU to 1550 bytes, because each packet is going to be 1550 minimum, I'm telling you. If the overlay traffic is much more bigger, then make sure the underlay has got jumbo frame. That is 9000, okay? Jumbo frame size is 9000 bytes. All Nexus supports this. So don't forget to increase the MTU size. If the default host traffic with the default MTU, then you need to just increase 50 bytes in the physical VXLAN fabric. It's enough. But if the sender, the host itself is sending big size, 3000, then you just go and enable jumbo frame, which is 9000. Sorry.
Yes,
Is
sir.
this clear? 50 bytes. Don't forget.